in the net present value for the annuities. And here today we will talk about the annuities when it is ordinary and when it's due. Let's go to an example like this directly. And so the annuities, when you see in the example the word annuities, and we see that we have also annuities, and we have to calculate the present value of annuity. The word annuity means what? Means that amount of money, similar amount of money is paid on similar times, on similar periods of time, and with interest rate, compound interest rate. So I have to look for the compound interest rate, the word annuity, and its similar amounts paid on similar durations. As example here, every year for 20 years. So here, when I say every year for 20 years, that means that I have to deduct the data from this given example. The deposit is 50,000. How did I know that the deposit is 50,000? He said year, 50,000 per year for the next 20 years, for the next 20 years. So here is the 50,000. The amount is 50,000. Here it is. The amount is 50,000. Perfect. And the number of years, number of deposits or the annuities. How many times I went to the bank in these 20 years? So I went to the bank 20 times, 20 times. For each year, I went once. So I went 20 times in these 20 years. I went 20 times in these 20 years. The rate of interest is 6%. The rate of interest is annually 6%. How did I know? It's here in the example. He's saying with a rate of interest like here, 6% discount rate. And this is, of course, with compound interest. If it was simple interest, I'm not going to use the tables. But if it is compound interest, that's what I'm doing right now. Okay, we have two types of annuities. Ordinary annuity, the ordinary one. The ordinary one is usually paid at the end, of the year. This we call it the annuities, or this we call it, here we go. So this usually we call it ordinary annuity. Ordinary annuity means the amount PMT. How to get the present value? I will multiply PMT, which is the present or the deposit amount, multiply by 1 minus 1 divided by 1 plus rate of interest power. The number N is the number of the deposits. So again, PMT, which will be the $50,000, multiply by 1. This one is constant, minus 1 again constant. It's there. Divided by 1 constant plus rate of interest, which is 6% in this example, power the number N, or the number of the deposits, divided by the rate of interest again. So if I do this right now, it will take, I showed you in the classes how to do it on the calculator. But also, we can do it using the abstract from the tables directly. So I know now that this is table 4 because it's the present value for annuity, like I said before, and compound interest. So I have to go under 20 years times 6% and get the number which is there. 20 years times 6%. When I go there to the table here, I will go here. This is the table, 20 years, and my own number is 6%, which will make 11.4699. So I will take this now, this amount, 11.4699. I will take this amount right now, like this. Then I will say here, then the future or the present value will equal, let me caps it, present value will equal the 50,000 multiplied by, it will be multiplied by the abstract which we saw just now in the table. Let us get from the table back, 11.4699. That will be 11.4699. That I will multiply it by the calculators used here. I will multiply it by the calculator. Just let me get the calculator here. And I would get this number. Here we go. We have the calculator here. That's okay. Here. Okay. This is the 50,000 multiplied by the number which we had right now, which is 11.4699. Let me take 11.4699 multiplied by. Here is the calculations. 50,000 by 11.4699. That will equal how much? $573,495. 573. Then this number, I will take it like this, Control and C, and I will go and paste it there where the answer is. Here it is. That will equal, and here is Control and V. This, of course, in dollars. In dollars. So this was the first thing. If we had ordinary, that's what I'm saying. If we had ordinary, an ordinary amount, if it is ordinary amount, that's what we will do right now. Then, if it was not ordinary amount, if it was not ordinary, as example, if it was due, then we'll multiply by 1 plus R. R is 6%. So this amount again, if it is due, I will do like this, simply same abstract which I got, but I will multiply by 1 plus R. So this is the ordinary one. So with this first will the ordinary. To calculate the ordinary, here it is, ordinary, which is usually paid at the end of the period, which is paid at the end of each period. Hey guys, this is the ordinary. Now, I will do the due. I will do the due. So I will do the due second, the due, Control and V, the due here, paid at the start or beginning, at the start or the beginning of each period. What I will do, same what I did here, like here, exactly the same data, the same everything, Control and C. But what I will do actually is to multiply back in 1 plus R. Control and C, Control and V here. And I will just take also the, to show you, we'll take the formula and put it here for you guys so that you can see it, be clear for you in front of you here. Here it is. Here it is, multiply by R again. So what I will do actually here in for the due is just, this was for the simple, this was for the ordinary amounts. This was for the indirect. This is the formula for the ordinary, like we did before. This is the formula for the ordinary. Then this is the 20 years, 20 times, because once every year, 6% is the interest rate compound, and the amount is 50,000. And when we multiplied here already, and we got this, so I got the 50,000 multiplied by what? This is what we abstract from the table. So this number, 1 minus 1 divided by 1 plus R, or N divided by R, this is what we get the value, which we get from the tables directly, which we get directly from the tables here. This is the tables, and this is what the value which we get from the table for 20 years, this number which we had. So it's substituted instead of this part of the formula. But now for the due annuities. Due annuities, which is paid at the start of every year, at the start of every year. So here is the dues annuities, which is paid at the start of every year. I will take the formula also screen here. I will take it like this way and just put it for you there so that you can see it and be clear for everyone. Here I will say edit, copy. Then I will go here into the solution again of my example. And I will say this is the due now. I'm in the due right now. I'm calculating the due, which is the second part, the due. So here to say that due is the same example which we had, but multiply again by 1 plus R. So here the same. This exactly, plus again multiply by 1.06. Why? Because 1 plus 6% will give me 1.06. So that's what I will do again. But I will take the number from the calculator back, the numbers which we had, or I can take it from the exercise which I did before. This is the number, Control and C, and I will multiply it by, so this will equal Control and V, multiply by 1.06. So what I did actually, I took the ordinary and multiplied by again 1 plus the rate of interest to get the due one. So this amount will be 573. Let us say here 573 495 573 495 multiply by, let's see, multiply by what? Multiply by the amount here, 1.06. 1.06. Here it is. Multiply by, here we go. We don't need this. We were working on the other one. Here it is. This one also we don't need it. We open many calculators actually. Here in this example, we did many calculators. So it's okay. No worries. We can multiply it like this right now. Here it will be 573. Let's see here. Yeah, this is the one. Multiply by 1.06. That will equal. So this amount. This is the amount which we will get from the due. Seemed to me very well, and seemed to you that due that will equal. And here we'll put the results here. Seemed to me and you that the due annuities is greater in the amount than the ordinary. The ordinary is 573,495, but the due is 607,904.7 dollars. This is dollars, of course. So that means that the amount due is always greater than, here we'll insert special symbols, is greater than the amount ordinary, because simply it stayed in the bank more. It stayed in the bank more. For that reason, the amount here is greater than this amount. As you see here, let me sum again. How did I know that this is ordinary or non-ordinary? How will I know? I will know this is ordinary or non-ordinary from the that you say this is annuities. How will I know it's annuities? I will know annuities from that it's a simple amount is paid on a simple period. So we have $50,000 is paid every year for 20 years. Every year, so 20 divided by 1, that means N will equal N. The number of annuities will equal 20 times. And I have also the principal, or the each time I go to the bank, I pay $50,000. So here, when I will say 50,000 is the P, and the 20 divided by 1, which 20 times is the N. And when I get the ordinary means paid at the end of each period. This is the abstract. This is the number. So it will be the 50,000 multiplied by 1 minus 1 divided by 1 plus R, or N divided by R, whereas the R is the rate of interest and the N is the number of deposits, or the number of annuities which I put in the bank. Then instead of just multiplying and getting this substituted in the formula, instead of that, we go directly into the table. So we go now, we need to see 6% for 20 years. How much it will make annuities? I go here down into the tables. I go to the tables. Here the tables are. I go to the tables, and there I will go to 20 years. This is N, the year number of years. This one, this column, the number of years, and I will go under 6% here. This is the 6%. 6% and 20 years, they intersect here for 699. Then again, I will go and multiply 50,000 by 11.4699. That will give me this amount, which is at the end of the period, which will be $573,495. But the due means that you paid at the beginning or the start of the period. So here I will say the PMT, the same amount, it's 50,000. Again, in the abstract, the same abstract which I had from the table again, but this time I will add 1 plus R. So it will be multiplied by 1.06, which is the interest rate plus 1, because 1 is constant. So the difference between the annuities ordinary, that it takes this formula, this takes this figure only, but the due, we multiply again by 1 plus R. This is the only difference. So based on the example, you will see, is it due or ordinary? Due, then you will multiply by 1 plus R, like here. So the same what we did here in the ordinary, the same thing which we did in the ordinary, same again, we repeat it back in the due, but this time we'll multiply by 1.06. So this is the final answer. Now it seems to you very clear that the amounts due, look at this 607, is greater than 573, of course, 0.495 or 495 times. That was the annuities, the present value of the compound interest annuities, either ordinary or due. Thank you.